Alright guys, so today we're going to talk about alkene hydration. And while there's many forms of hydration, we're going to talk about an alkene being acid catalyzed. And so one way we can do that is with the reaction with water and sulfuric acid. Now, of course, another way to write this is to draw a hydronium ion. Because in a natural solution involving these two molecules, H2SO4 will pronate water, and that will get us hydronium ion, which is also an acid. When we do this reaction, we'll end up with an alcohol on our more substituted side, and this is what we call Markovnikov's rule. So anytime we have a substituent, such as this alcohol here or another functional group, we always want to add it to a more substituted side, and there's very few exceptions when it comes to Markovnikov's rule. So here is the mechanism as follows. So first, let's bring in our alkene. There's our double bond, and we'll bring in our hydronium ion. Now, of course, when it comes to the total reaction, we're not doing the mechanism, we can just draw the two molecules you see up here. But in the mechanism itself, you'll want to draw hydronium ion to show the steps properly. So first what's going to happen is that this alkene is going to take this hydrogen, and we're going to move this bond onto our oxygen as a lone pair. So we're moving the electrons. So now what we'll get is a carbocation on our more substituted side. So our hydrogen will be added to our less substituted side, because remember, this is Markovnikov's rule. So now what we'll do is we'll bring in our water that we just formed by depronating that hydrogen in the first step. There's two lone pairs in the oxygen, and the lone pair will form a bond with our positive charge on a carbon right there. So now what we'll get is we draw our hydrogen in here still, stay on track, and then we have our water molecule right here attached. Now there's three bonds, so it has a positive charge. So now what's going to happen is that we're going to bring in a water molecule, and one of the lone pairs in the oxygen is going to depronate a hydrogen off of our oxygen attached to our carbon-carbon bond right there on our molecule. So now what we'll get is our final product. Our hydrogen still attached right here. And then we have our alcohol product right here as well. Additionally, we form a byproduct, which is hydronium ion. So this allows us to do the reaction again if needed. Now to touch onto stereochemistry real quick, this is not stereoselective. That means that our end products will be a mix of anti and syn products. So our OH and our H can either be syn, like we have it in this example, or they could also be anti. And the way we could draw that is we draw our constituents like this, and then here's our bonds. Our alcohol will be here, and our hydrogen will be down here. So this would be our anti-product. So these two would both work. So that is the complete reaction and mechanism for alkene hydration via an acid catalyzed pathway. And I hope this helps. Have fun with it, and I'll see you guys in the next video.